Ionization potential of a hydrogen atom is 13.6 volt. Hydrogen atoms in the ground state are excited by monochromatic radiation of photon energy 12.1 electron volt. Spectral lines emitted by the hydrogen atoms according to Bohr's theory will be 1, 2, 3 and 4. These are the options. So, final energy, ionization potential means you are taking out the electron completely from the ground state. Okay, that is 13.6 volt. Whereas the energy there in the ground state is 13.6 electron volt. So, now ground state is excited to photon energy 12.1 electron volt. Okay. So, final energy is equal to ground state energy plus applied energy, applied photon energy. Correct? See, when the transition takes place from higher orbit to the lower orbit, energy is released. When electron gets de-excited from higher orbit to the lower orbit, the energy is released. Similarly, if the same amount of energy is absorbed, the electron from the ground state absorbing this amount of energy delta E gets excited to the higher energy. So, that is the final energy. So, if delta E is, this is E2 and this is E1, delta E is E2 minus E1 for radiative transition, for radiation or emission. Okay. Similarly, for absorption, so the final energy E2 can be delta E plus E1. That is what exactly has been written up. Now, it absorbs a photon of energy. How much? Applied photon energy is 12.1 electron volt, and here we have the energy minus 13.6 electron volt. That is the final energy, which is minus 1.5 electron volt, E2. So, E2 or E final I will call it, E final if I call it, that corresponds to minus 13.6 by n square. So, n square is minus 13.6 by 1.5, because this is 1.5 minus 1.5 electron volt. So, n square is 4, n square is rather 9, n is 3, correct? Now, total number of possible transitions, is given by n into n minus 1 divided by 2. So, here we got n is equal to 3 minus 1 by 2. So, this is 3 into 2, 6 by 2, that is number of transitions possible is 3 itself. We will take a look at this. See, this is n is equal to 1 level, this is n is equal to 3 level, this is n is equal to 2 level. So, the possible transitions from there is 3. See, 3 to 1, 3 to 2, then 2 to 1. These are the possible transitions. So the number of possible transitions is 3, which is option C being the correct answer.